Okay, example 5 talks about finding the domain of a function. The domain of a function is essentially the list of all x's. So in this situation, the domain is -3, -1, 0, 2, and 4. Because the x's for all the ordered pairs make up the domain. Okay? Sometimes it gets a little more challenging than that, such as g of x equals -3x squared plus 4x plus 5. And essentially on a polynomial function like this, the domain is going to be all real numbers. Because I can put any number in for x that I want to. Things to look out for when you're talking about the domain of a function are square root signs, because anytime you see a square root sign, the square root sign has to be greater than or equal to 0. Other things to look out for are fractions, because when you see a fraction such as 1 over x, you have to take the bottom x and set it equal to 0 and solve, and that's what x cannot be. So let's take a look here at part C, where it says h of x equals 1 over x plus 5. We know that the bottom of a fraction can't be 0, so we have to find out what number for x makes the bottom 0. So we say x plus 5 equals 0, just like we talked about here, it's a fraction. So x equals -5. That means the domain of this function is going to be x can be all real numbers such that x cannot equal -5, and that is my domain here. All real numbers such that x cannot equal -5.